Hello everyone and welcome back to Level Up STEM for our third video of the Calc 1 practice problem series. Make sure you like and subscribe. So in this problem setup we have a particle moving across a straight line in distance s measured in feet to the right of a fixed point at time t minutes as given by the graph in the figure. And our first question is asking over which time interval is the particle moving to the right. So for this one I think it's important to draw the velocity graph from this. And that's just the derivative of the s function. So to do that, we see it's positive sloped here, so it's going to start positive and zero out at the peak. And then you see it's a pretty steep slope. It's going to level back out to 0 at 3. And then go back here, level out there. And you can determine that once again just based off the slope. That's a pretty rough estimate of what it should be. But we can see from this that it's basically where it's positive, it's moving to the right. And so we see it's about 1 to a little over 1, maybe call that 1.5. So from 0 to 1.5, and also from 3 to 6, based off of that graph I drew. And yep, that's the answer. So over for question B, we have over which time interval does the particle have negative acceleration? So one way to go about this would be to, again, draw another derivative graph based off the velocity one I drew in the last part. But I think an easier way to go about this is by determining which parts of the graph is concave up and concave down. So for this one right here, you see it's concave down because it's a, I guess, negative, it's like a frowny face. And this is like our smile, which means concave up. And again, concave down here. So we see from that the concave down parts of the graph correlate to the negative acceleration or the negative second derivative. So that looks like it's from 0 to 2 and also from 4 to 7. And yep. And so for this one, at approximately which time does the particle have the highest speed? Recall that speed is the magnitude of the velocity. Explain your answer. So for this, I went ahead and put in the graph I drew in the first part for the velocity of the particle. And you can see that in between right here around 2, it has a really high negative slope. And that's the key here because that makes this dip really far for our velocity. And remember, the highest speed can either be the highest in the negative direction or the highest in the positive direction. So the highest speed looks like to be occurring at about 2, time equals 2. And yep, there you go. So yep, there's this video.